and this decay and do the other thing. Not because they are easy, but because they are hard.
We've got to have the discipline to not be afraid in mathematics when things look difficult. Especially in mathematics, when things look difficult, they're probably very, very powerful. That's what the case is going to be with rational exponents. That's exponents that are fractions. Eventually, if we can master them, we'll be able to master what an animal called a logarithm, which will bring all kinds of nice tools to us. Let's review what we're supposed to know about exponents that we may have forgotten. For instance, the weird things that might scare us, like 0 as an exponent. Now, he has to follow all the rules of exponents, and the first rule of exponents when you multiply them is that you add them, right? 2 plus 0 is 2. Well, 5 to the second times 5 to the 0, if that equals 5 to the second, one has to ask oneself, what could you multiply 5 to the second by to get itself? Well, what can you multiply anything by to get itself? 5 to the 0, in this case, must equal 1, right? Because you'd have to multiply 5 to the second by 1 to get 5 to the second. And it has to follow the rules.
I know you are, but what am I?
So 5 to the 0th is 1. Not 5 to the 1th, it's 1. And in fact, any number to the 0 power
Or not.
has got to result in the value 1. Do you remember what we do with negative exponents? This symbol, now I want to say negative, I'm going to call it opposite, because there's really two opposites. It really matters where you put that slash symbol, which you call negative. If you put it out front, in front of the x, yeah, we always call that a negative. It's like a negative temperature or something like that. That's an additive negative, okay? Or an additive opposite. When we put it in this position, up with the exponent, it's not an additive opposite, but the other type of opposite, it's a multiplicative opposite. And we have a word for that, so that you're not confused. The multiplicative opposite is called the reciprocal, isn't it? So x to the minus a isn't a negative number at all.
That's the fact.
It's actually a fraction. It's the reciprocal of x. 1 over x to the a.
Not because they are easy, but because they are hard.
Okay, now let's get to the things that you've never seen perhaps before. We know whatever we do has got to follow this rule. X to the a times x to the b equals x to the a plus b.
Allow me to demonstrate.
For instance, x to the second times x to the third equals x to the fifth. Well, okay.
Hold on, little fire, Scarecrow.
Still got to follow the same rule. X to the half times x to the half. What is a half plus a half? It'll be x to the... Don't be afraid. It's the same thing. You know what a half of a dollar plus a half of a dollar is.
I'm trying to think, but nothing happens.
Don't get nervous. A half plus a half is 1. A half plus a half is a whole.
I know that, dude.
That's easy. Okay, of course, we usually don't write the 1, do we? So what does this lead us to? Well,
Excuse me, Professor Brainiac.
believe it or not, x to the half stands for something that you already have seen. If x to the half times x to the half equals x, it's the same as the square root of x. Because if we have to multiply it by itself to get x, that's what it means to be the square root of x, doesn't it?
I am not programmed to respond in this area.
Now don't get nervous on me. Let's take this a step further and talk about x to the third. If x to the half is the square root, x to the third, remember, what is a third plus a third plus a third?
Something's happened to my brain. It's all dried up.
Don't get nervous. A third plus a third, that equals 1 as well, doesn't it? Which we usually don't write the 1.
Gee, let me think.
So x to the third will be the same as another way of writing
Shazam.
the cube root of x. Now, we can use other fractions as well. So in general, x to the 1 over some number n, like the 1/4, the 1/5,
But now you know. The rest
is the nth root of x, the 5th root of x, the 6th root of x. That's why we say the 5th root of x or the 3rd root of x, because we actually write a third, don't we? Okay? Now let me take this one more step further. Let's take that cube root of x
Now what am I going to do?
and raise it to a power. Ooh. I want to represent that in a fractional exponent, and I certainly can do it. If you consider that x, the cube root of x, is x to the 1/3, and remember the rules for dealing with exponents and parentheses. Do you remember? You multiply in this case. And what's 2 times a third? This expression could be represented as x to the 2/3.
Not because they are easy, but because they are
Let's
hard.
do another one with a root
Yes, you're in deep do now.
to a power. Okay? This expression
Wait a minute.
could be represented, well, the 4th root is x to the 4th. And remember the rule, 3 times a 4th, this expression could actually be represented as a rational or fractional exponent as x to the 3/4. There's going to be an advantage to that because we can manipulate. We're supposed to be able to manipulate fractions. We can add fractions, subtract, multiply, divide fractions. Okay? So this is going to be a better way, a more flexible way to write that.
Prepare to be astonished.
So in general, x to the m over n really means the nth root of x, whatever n is, to the mth power. And there's going to be two ways to write it. The way on the left is a rational or fractional exponent. The way on the right we call radical notation. Okay? And you have to be able to go back and forth between either. I want you to be able to go backwards, for instance.
And now, ladies and gentlemen, let's get ready to rumble!
Let's try and simplify this. Well, it's kind of difficult in this form. Maybe if we write it in radical form, it'll simplify. And that's what we're going to try and do. The trick here
Excuse me?
is to do each number separately. Okay? The 3, of course, is in the top. That 2, I don't want to say it's a 2. I want to say it's a half because he's in the bottom. Okay, and I'm going to execute the half first because that'll make the number lower. That's the root. I want to make it lower first, then the power will make it higher. So I'm going to do the root first, 16 to the half, and then I'll raise that to the 3rd power. Now, recall, 16 to the 1/2 really means the square root of 16. And I'm going to make all these come out even for you, okay, at least for now.
Woohoo! Come to
The
Papa!
square root of 16 is 4. And now, 4 to the 3rd power, 4 times 4 times 4, equals 64. So actually, 16 to the 3/2 power equals 64.
Do that again.
Okay, I promise you this one's going to come out even. So I'm just trying to get you to remember the rules. And once again, the trick
Excuse me?
is to treat each one separately. So we're going to have 32 to the 1/5 power. We'll do that first, get an answer, and then raise it to the 3rd power. Now 32 to the 1/5 is the 5th root of 32. And I'm promising you that's even. Do you know what the 5th root of 32 is? Well,
Oh, yes.
it's 2. You know why? Because 2 times 2 times 2 times 2 times 2 5 times equals 32. Okay? Then we take 2, raise it to the 3rd,
Fascinating.
and you get 8. So we want to relax your brain so that you can see anything in an exponent. Fractions, or negatives, or 0, or anything. 1,000 to the 2/3 power
No problemo.
is going to be, breaking it up into the two numbers, 1,000 to the 3rd to the 2nd power. Now 1,000 to the 3rd is the same as writing the cube root of 1,000, isn't it? And the cube root of 1,000, once again, I'm going to make it come out even for now,
You look marvelous.
is 10. Okay, and then of course 10 to the second power
Brilliance. That's all I can say.
is 100.
Unadulterated brilliance.
Now we got that idea. That equals 100. 1,000 to the 2/3 equals 100. What about 1,000 to the negative 2/3? Because we can have negatives in exponents as well.
Whoa! Someone smells stinky.
No, it's not that bad. Remember what negative means in an exponent. Not out front, where it's additive. In an exponent, it means the reciprocal. But we're still going to do it the same way. Let's do the 1/3 power first. Then we'll raise that answer to the negative 2 power. Well, we know 1,000 to the 1/3 is the cube root of 1,000, which comes out even,
Correct, boy wonder.
is 10. Now what is 10 to the minus 2? Recall what negative in an exponent means.
Sinister forces are at work.
It means the reciprocal. So really what we've got here is 1 over 10 to the 2th.
Oh, no!
The answer is 1 over 100. And please note that it is not a negative number, is it? It's a very small number, but it's not negative. So negative exponents basically do not create negative numbers. They create small numbers, especially in science. Now, I think we already know how to find square roots with your calculator. We're going to use this button, the x squared button, in combination with the second button and the enter button. Turn that baby on, and basically we'd hit second x squared, and what would that do? That would give us the little square root symbol, and then you'd type the number that you want to take the square root of. For instance, if I type 16, I of course would have to hit enter to tell it I'm done typing the number, and it would give me the square root of that number, 16. Or 6 squared of 16 is 4. Okay? But
Now what am I going to do?
that doesn't help me in taking the cube root of a number, perhaps, or the 4th root or the 5th root. Okay? I want to show you how to do that, and rational exponents are certainly related.
Now I want answers, I shall have answers.
Okay, we can get these answers of higher roots with a calculator using rational exponents. That's the exponent key.
Whoa!
Now, whenever you have exponents, you're going to have to use parentheses. Hopefully, I'll show you why in a second. But definitely, any exponent has to have parentheses around it to force the correct order of operations. If you turn that baby on, and you put in 64 to the 1/3 power with exponents, parentheses around the exponents. Okay, what is 64 to the 1/3 power? Well, it's the cube root of 64, isn't it? If you hit enter, you get the 4. Okay, it's not the square root of 64, 8. It's the cube root of 64.
Pay attention, son. This is for your own good.
It's very important that you understand why we have to put those parentheses. If we didn't put them, it would follow the order of operations, which is to do exponents first, then division. Basically, it would raise 64 to the 1th power, get 64, and then divide it by 3, and you wouldn't get the cube root. Okay? 81 to the 1/4 power, what would that equal? That would be the 4th root of 81. Not the square root of 81, 9, but the 4th root. If you hit enter,
Excellent.
you get the 4th root, which is 3. Think about it. 3 times 3 times 3 times 3 is 81. Don't forget, though, you have to put these parentheses. That's the most common mistake in these kind of problems. So, in review, rational exponents can be written x to the 1 over n, which means
Now you know. The rest.
the nth root of x. And
Prepare to be a
if we have a value in the numerator, m, x to the m over n really means the nth root of x to the mth power. Okay, and you should be able to go back and forth between those two types of notation.
Hasta la vista, baby.
Go practice it.